What causes earthquakes, volcanic eruptions, and the rise of mountains like the Himalayas? The answer lies beneath our feet. Powerful forces move massive tectonic plates shaping our planet. The Himalayas are a stunning example of this ongoing process. Earthquakes, volcanoes, and mountains all result from this restless movement. This is the story of how the roof of the world, the Himalayas, was born. Imagine Earth's outer shell as a cracked eggshell, fractured into about a dozen major plates and many smaller ones. These tectonic plates are made of the crust and the uppermost mantle, forming the rigid lithosphere. Some plates, like the Pacific Plate, lie beneath oceans. Others, like the Eurasian Plate, carry continents. The plates fit together like a giant shifting puzzle, with no gaps between them. The action happens at the boundaries where plates meet. Earthquakes, volcanoes, and mountain building all occur here. The centers of plates are relatively stable, but the edges are dynamic and dangerous. Beneath the plates lies the asthenosphere, a hot, ductile layer that allows the rigid plates to move. The lithosphere floats atop this slow-moving, semi-molten mantle. There are 7 major plates and several smaller ones, each moving in its own direction and speed. Their movement is driven by powerful forces deep within the Earth. This constant motion is the engine behind the ever-changing face of our planet. Next, let's see what drives these plates to move. What powers the movement of tectonic plates? The answer lies in the intense heat deep within the Earth. This heat creates slow-moving convection currents in the mantle, much like boiling water circulates in a pot. Hot rock rises, cools near the surface, then sinks again, dragging the plates along. These convection cells act as conveyor belts, moving the plates over millions of years. The plates move slowly, just a few centimeters per year, about as fast as your fingernails grow. Over millions of years, this adds up to continents drifting and mountains rising. Other forces help too. At mid-ocean ridges, new crust pushes plates apart, ridge push, while at subduction zones, sinking plates pull the rest along, slab pull. Together, these forces keep the plates in constant dynamic motion. It's a slow but relentless process that shapes our world. Now let's look at what happens where these plates meet. The boundaries are where Earth's most dramatic events unfold. The real action in plate tectonics happens at the boundaries where plates meet. There are 3 main types: divergent, convergent, and transform boundaries. At divergent boundaries, plates pull apart and magma rises to create new crust, like at the mid-Atlantic ridge. At convergent boundaries, plates collide. If oceanic and continental plates meet, the denser oceanic plate sinks beneath the other, causing subduction, earthquakes, and volcanoes. The Pacific Ring of Fire is a hotspot for this activity. At transform boundaries, plates grind past each other horizontally, building up stress that's released in earthquakes, like California's San Andreas Fault. Sometimes, 2 continental plates collide. Neither can sink, so the crust buckles and rises, forming huge mountain ranges. The Himalayas are the world's best example of this kind of collision. These boundaries are the engines of Earth's most powerful geological events. Each type creates unique landscapes and hazards. The collision of India and Eurasia is a prime example of continents in motion. Let's explore how this collision built the Himalayas. The Himalayas were born from a spectacular collision between the Indian and Eurasian plates. 50 million years ago, India was a separate landmass, racing northward toward Asia. As the Indian plate collided with Eurasia, the ocean between them closed, and ancient seafloor sediments were thrust upward. Fossils of marine life now rest atop the world's highest peaks, a testament to their oceanic origins. Because both plates are made of buoyant continental crust, neither could sink. Instead, the crust crumpled, thickened, and was forced upward, like 2 cars in a slow-motion crash. This immense pressure folded and stacked the rocks, building the towering Himalayas and the vast Tibetan Plateau. The collision doubled the crust's thickness, creating a deep root beneath the mountains. The Himalayas are a textbook example of continent-continent collision. Their formation is a dramatic display of tectonic power. But the story doesn't end there. The mountains are still rising. The Himalayan collision is ongoing. The Indian plate still pushes north into Eurasia, making the mountains rise by millimeters each year. The region is one of the most seismically active on Earth, with frequent, sometimes devastating earthquakes. The 2015 Nepal earthquake was a stark reminder of the energy stored in this collision zone. The collision not only pushes the mountains upward, but also squeezes the crust sideways, causing the Tibetan Plateau to spread eastward. This tectonic escape triggers earthquakes far into China, showing the collision's vast influence. The Himalayas are not ancient relics. They are a living, growing range. Every jagged peak and deep valley is evidence of continents locked in a titanic struggle. The landscape is constantly being reshaped by the slow, unstoppable movement of the plates. The region's people live with the risks and rewards of this dynamic geology. The Himalayas remind us that Earth's surface is always changing. We are witnessing geology in action. The story of the Himalayas is still being written. Understanding plate tectonics isn't just for scientists. It affects us all. Most earthquakes and volcanoes occur along plate boundaries, so knowing where plates move helps us prepare for natural disasters. This knowledge guides building codes and early warning systems, saving lives. Plate tectonics also explains where valuable resources like minerals, oil, and gas are found. The movement of plates concentrates these resources in certain regions. The theory unifies our understanding of Earth's history, from drifting continents to changing climates. Volcanic eruptions can alter global temperatures, while rising mountains reshape weather patterns. Plate tectonics shows us that Earth is a living, evolving planet. Continents drift, oceans open and close, and mountains rise and erode in a never-ending cycle. This perspective reminds us that our world is not fixed, but always in motion. We live on a thin, moving crust, on a planet that is very much alive.